What is pacemaker potential? Give its causes. Presence of pacemaker tissue in the heart that can initiate repetitive action potential. It is characterized by unstable resting membrane potential minus 50 millivolt because of slow depolarization between the action potential and action potential called pre-potential or pacemaker potential. This is due to slow decrease in potassium efflux with a transient increase in calcium influx. Why is SA node called cardiac pacemaker? Because resting membrane potential in SA node is minus 50 millivolt, closer to threshold excitation of minus 40 millivolt. The rate of rise of pre-potential is highest, that is 15 to 60 millivolt per second. What will happen if SA node is destroyed? And then next fastest latent pacemaker, that is AV node, takes over. A rhythmic rate of discharge in AV node is 40 to 60 beats per minute, and that of Purkinje fibers is 15 to 40 beats per minute. Name types of cardiac action potential and give their differences. Site, atria, ventricle, the fastest response and the slow response. Fastest response from SE node and AV node, and the slow response from atria, ventricle and Purkinje fibers. Resting membrane potential in fast fibers is minus 90 millivolt, whereas in slow fibers it's minus 50 to minus 90 millivolt. The action potential in zero phase, the slope is upstroke and amplitude and extent of overshoot is greatest, whereas zero phase has slow velocity. Repolarization is slow and shows three phases: phase 1, phase 2 and phase 3, whereas phase 2 plateau is absent. Phase 3 the velocity is more gradual, and phase 4 characterized by pacemaker potential. Conduction velocity is fast, whereas conduction velocity is slow. Name factors affecting cardiac muscle membrane potential. Give their mechanism of action. Acetylcholine or vagal stimulation acts via M2 muscarinic receptors, decreases heart rate. Negative chronotropic effect due to threefold increase in potassium efflux of SA node. Decrease intracellular cyclic AMP, thus decreases the force of myocardial contraction by decreasing calcium influx. Negative ionotropic effect. Epinephrine and sympathetic stimulation acts on beta 1 adrenergic receptors, causes increase in heart rate. Positive chronotropic effect due to increase in calcium influx of nodal tissue. Increases myocardial strength of contraction by increasing the calcium influx of the myocardial fibers, which is called as positive ionotropic effect. Temperature increases in internal body temperature within the physiological limit, increases heart rate and increases calcium influx of nodal tissue, and increases the force of myocardial contraction by decreasing the viscosity. Decrease in the internal body temperature, opposite effects will be there. Increase in potassium by 2 to 3 times, normally 4 milliequivalent per liter in ECF, the potassium value. Increase in potassium decreases heart rate, decreases strength of myocardial contraction. Finally, stoppage of a heart in the diastole. Mechanism: defective conductivity and gradually loss of excitability. Decrease in potassium in ECF, usually no effect. Calcium: increase in calcium in ECF increases myocardial contractility, heart relaxes less in diastolic, and finally stops in systolic. Calcium rigor: the decrease in calcium in ECF decreases myocardial contractility. Sodium: decrease sodium in ECF, no effect. Increase sodium in extracellular fluid, decreases myocardial contractility as sodium competes with calcium in contractile process. What is AV nodal delay and what is its physiological significance? Cause: slow conduction of the AV node, that is 0.05 meters per second, and duration is 0.1 seconds. Physiological significance of AV nodal delay: it ensures proper ventricular filling before contraction, limiting the impulses that can be conducted through AV node approximately 180 beats per minute, protects the ventricles from being driven at excessive rates. List mechanical properties of cardiac muscle: contractility, all or none law, and refractory period. Give duration of mechanical response in cardiac muscle and what is its significance. Contractile response begins just after the start of the depolarization and lasts until 50 milliseconds after repolarization is completed. Thus, contractile response is more than half over during the action potential. What is effect of preload on heart? It is the degree at which the myocardium is stretched before it contracts. Its extent is determined by the end diastolic volume, that EDV. Normally it's 130 to 140 milliliter. What is Frank's Starling law of heart give its significance? Within the physiological limit, force of contraction of ventricular muscle fibers is directly proportional to its initial length. Significance: it ensures that blood ejected by each ventricle per heartbeat is the same. It is also a life-saving device in heart failure. Which part of art obeys all or none law? This principle applies to the whole of the functional syncytium in the heart. The unit begins either the entire atria or entire ventricle. Give duration of normal refractory period of the heart and what is its physiological significance. Normal refractory period of ventricles is 250 to 300 milliseconds and that of atria is 150 milliseconds. That's why the rhythmic rate of contraction of the atria can be much more faster than the ventricles. Normal duration of absolute refractive period is 180 to 200 milliseconds and that of relative refractive period RMP is up to 50 milliseconds. Significance: cardiac muscles cannot be tetanized because summation of contraction, since the whole contraction phase is over during the absolute refractive period. Justify heart to function throughout life without showing any sign of fatigue. This is made possible by abundant blood supply, that is 80 ml per 100 grams per minute compared to skeletal muscle blood supply, which is 3 milliliter per 100 grams per minute. Presence of numerous mitochondria, power generating units, high myoglobin content, and oxygen storing muscle pigment. Working condition: completely aerobic with essentially no accumulation of lactic acid. Main source of calories need at rest to meet by hydrolysis of fat, sparing the carbohydrates. The difference between the single unit and multi-unit smooth muscles. Single unit or visceral smooth muscles, multi-unit smooth muscles. Single unit occurs in large sheets, has low resistance bridges between the individual muscle cells, and it functions as syncytium fashion. Multi-unit smooth muscles. No syncytial in character, contractions are more discrete, fine and localized. Single unit or smooth muscles, wall of hollow viscera, GIT, uterus, bronchus, uterus or urinary bladder. Multi-unit smooth muscles are present in iris, ciliary muscles of eye, pilorector muscles of the skin and the muscles of blood vessels. A single unit smooth muscle characterized by the pacemaker, which gets modified by extrinsic innervation. A multi-unit smooth muscle is richly innervated and each muscle fibers has its own nerve supply. Rhythmic contraction and relaxation of these muscles, these single unit muscles, is independent of their innervation. Here, in multi-unit smooth muscles, single stimulus to the nerve causes repeated firing action potential, which produces irregular tetanic contraction. In single unit smooth muscles, if these muscles are stressed, there will be production of active tension. These muscles do not respond to stretch. Multi-smooth muscles. Which smooth muscles as properties of both single unit as well as the multi-unit visceral smooth muscles. What is the property of plasticity? Absence of any constant relationship between the muscle fiber length and tension is known as plasticity. What is latch bridge mechanism? Smooth muscle sustains contraction due to myosin cross bridges remains attached to the actin even after decrease in the intracellular calcium. What is excitatory junctional potential, EJP? That is, smooth muscles where adrenergic discharge is excitatory stimulation leads to discrete partial depolarization similar to small end plate potential. This potential summation with repeated stimuli. What is deinnervation hypersensitivity? Deinnervation of smooth muscles leads to it becomes hyper responsive to the chemical mediators that normally activate it. Causes deficiency of given neurotransmitter. Increases the number of active receptors for the transmitter. Give factors affecting the membrane potential on the intestinal smooth muscles. Effect of catecholamines or stimulation of sympathetic nerve acts via both alpha and beta adrenergic receptors, which leads to increased calcium efflux. Hyperpolarization of the membrane and decreases the spike frequency, which in turn decreases the muscle tension or the tonus and causes muscle relaxation. Effect of acetylcholine or stimulation of cholinergic nerve increases the calcium influx, causes membrane depolarization and increases spike frequency, which increases muscle tension, which leads to muscle contraction. Similar effects are seen with the cold and stretch. Effect of ions: increase in calcium extracellular fluid, increases sodium influx, increases the height of contraction. Barium increases the efficiency and the force of contraction. Direct effect: increase in sodium in ECF, there will be no effect. Important values to remember in this chapter: degenerative changes in the peripheral neurons begins within the 24 hours to 48 hours of nerve injury and reaches maximum by 15 to 20 days. Schwann cells grows at 1 to 2 millimeter per day and can bridge the gap up to 3 centimeters. Regenerative changes in the peripheral neurons begins in 20 days and completes in 80 days. Axial cylinder initial rate of growth is 0.25 millimeter per day and later 3 to 4 milliliter per day. Schwann starts lying down myelin in 15 days, which is completed by 1 year. Miniature end plate potential MEPP up to 0.4 microvolt, gained end plate potential up to 12 millivolt. Sarcomere length at rest is 2.5 micrometer. This is all about the important questions from the chapter Now Muscle Physiology. If you find this video helpful, please do like, share, and subscribe to my channel. If you have any suggestions, let me know in the comment section. Thank you.